All right, welcome to class. Make sure that you are finding your seats right away. We have a lab to do today. And for all of you guys, I'll wait until everybody is seated. Quickly, get to your seats. Thank you, Diana. Thank you, Kevin. Everybody should now have a lab. All right, today, class, we are going to be diving into true science, okay? Today is true science. Now, for today's class, I need somebody with a big voice to read today's objective. Dio, go ahead and take that bag off while you're at it.
Students will be able to determine the variables that affect the rate of chemical reaction by designing and conducting an investigation.
All right. Now, true science is all about making a prediction based off of what you see in the world, and you can see if your prediction is correct by testing it through an experiment. So today, you guys are going to design your own experiment. Now, today's lab is all about rates of reaction. Daniel. So we are going back to our unit on kinematics and equilibrium.
Kinetics.
What did I say?
Kinematics.
I'm blending together physics and chemistry into one. Okay, so to start off, we are going to go ahead and do a pre-lab reading, a short reading, and I need, let's take two big voices. I want to hear Marco and Tony. You're going to speak loudly and take off that bag. Any gum? No gum. Okay. So, go ahead and start us off with our reading right at the top.
The plop plop fizz fizz that occurs when
Antacid
tables are dropped in a glass of water has made Alka-Seltzer one of the most well-known marketing campaigns in history. However, when someone eats an antacid tablet, she is probably more interested in gaining relief from indigestion than the fizzing chemistry that takes place in the glass. As the tablet fizzes, it undergoes a reaction that can be timed and analyzed.
All right. So today, you guys actually do get Alka-Seltzer. In one of my other labs, we had the off-brand stuff, but you guys get the best. So we have Alka-Seltzer. And how many of you are familiar with Alka-Seltzer? Have seen it or heard of it?
What is that?
Okay. So Alka-Seltzer is an antacid. That means when you put it into your stomach, it helps your upset stomach feel better. All right? And it's used for different things like sore muscles and various things. But today, we are going to be investigating the rate of this antacid tablet. But let's figure out the rate of this reaction. And we want to understand what is it reacting with and what does it really mean. So for our next paragraph, go ahead, Marco, and read for us.
The major ingredients in Alka-Seltzer antacid tablets are aspirin, sodium bicarbonate, and citric acid. The fizz results when citric acid reacts with the base sodium bicarbonate to produce carbon dioxide, water, and a salt. The balanced reaction is...
Great. So we have a long balanced reaction here, but we know that, look, it says that we're reacting sodium bicarbonate, which is a base, and it's reacting with citric acid, an acid. What is the product of an acid-base reaction? Somebody with a hand. What is the product? Elena?
Salt and water.
Salt and water, of course. So today, we are going to be conducting an acid-base reaction inside of these beakers. Now, to understand this acid-base reaction, we need to investigate. So let's read this next paragraph all together. All of the ingredients for this reaction are present inside of the antacid tablet, but nothing happens until you put it in water. The tablet therefore provides you with a chemical package that can be used to carry out timed kinetics experiments. Now, factors such as temperature and surface area can increase the rate of this reaction, thus allowing a person relief from indigestion quicker. So, for today's lab, you need to be thinking about the rate of the reaction that's involved when we use antacid tablets. Can somebody please read for me the purpose of today's lab? Go ahead, Hector.
You are going to test a variable of your choice to see its effect on the rate of the chemical reaction.
Absolutely. So let's take a look at today's lab format, all right? This is a little bit different than what you've seen before, but this is so that you understand we're making strides to get you guys ready for college level and beyond science experiments, okay? And in life, you're not just given a packaged experiment, you have to actually create it and think through the process of how to design an experiment. So for today, the first step that we're going to take is forming a hypothesis. Then we are going to conduct the experiment that you designed, and we're going to collect data and finish off with a lab conclusion. Today, our goal is to finish this lab, all right? Many of you are just one lab away from reaching your lab minutes, and you just need to finish this. Work with me here today, push hard, and we're going to finish this lab step by step together as we move along. Go ahead.
How many points is this? 49.
49. One lab, class. All right. Let's take a look at some of the potential variables that we might test to test and figure out about the rate of the reaction for antacid tablets. So here are some of our potential variables. Can I get a reader? Let's just, how about you just read off for us one by one? You can shout it out. What's one of the things?
Pressure.
Gio, start us off, Gio.
Pressure.
Next.
pH.
Go ahead.
Temperature.
Surface area.
Solvent. Catalyst.
And?
Catalyst.
All right, so these are some of our potential variables, and I will tell you this. These are the supplies that you have for today. We have a timer. We have antacid tablets. We have thermometers. We have beakers. And I am giving you your very own access to water on either side.
Wow. Finally.
So, tell me, class, let's have some ideas. Let's have some ideas on which of these variables listed out might we be able to test in today's lab. I want to hear from Carlos and then Hector. Go ahead.
Solvent.
The solvent? Okay, so in this case, a solvent, what does a solvent do, Carlos? What does it do?
It's like when you put it dissolves something.
It dissolves something. So what would be doing the dissolving in this lab?
The water.
The water. Could we change the solvent
Yes.
It depends.
given what we have in lab?
No.
No, we couldn't change it. So if I can't change it, I wouldn't be able to test it and see does that affect the reaction. So think about another one. Let's hear from, I heard Hector, and then we'll go Marco and Ken.
And change the temperature of water.
Absolutely. I could turn the hot side of my faucet and get hot water, or I could turn the cold side and get cold water. What do you think I could do if I turn both sides on?
Warm
Warm.
water.
I could get warm water.
Oh my God.
So I could do that and watch your language. So now I'm thinking to myself, I could use temperature. So I'm going to star that in my mind. I could use temperature. What one other factor could I use? What else do you think, Marco?
Surface area?
How could I do that?
You can choose the amount that you want.
Okay, so can you talk me through? Why did you know I could use surface area?
Because you have it right there. You can put how many you want.
Okay, so how would you change the surface area of this antacid tablet?
By crushing it.
Okay, you could crush it up, and that's going to change the amount of area exposed on each particle. Great. So let's go ahead and think about a statement that we could make based upon those variables. This is not the statement that you're going to write down first, but this is just think it through. All right? If we wanted to make this into a complete sentence, it says the rate of the reaction between citric acid and sodium bicarbonate is or is not affected by, and today we've identified two variables, temperature and surface area. What I want you to do at this time is think to yourself, what could I do to finish off this sentence? What could I do to finish that off? And I want to hear from one person out there. Take a moment, think about how could I finish the sentence? How could I finish the sentence? Kenneth?
Like is affected by
Okay, so the rate of the reaction between citric acid and sodium bicarbonate, according to Kenneth, is affected by temperature and surface area. So this is something that I keep in mind. Now, we are going to move on to writing a testable question and making our hypothesis. To do this, you need to turn to page 2. Okay, on page 2, you will see that the first thing we're going to do is write a testable question. To do this, we need to break into our groups for today's lab. When I tell you to, you are moving into your groups and writing your testable question with your lab group. Now, before you move, a testable question takes the form of a question. So, we said that we had a statement here that this reaction is affected by temperature and surface area. How could I change that into a question form? How could I make that into a question? Marco?
Will surface area and temperature affect the rate of reaction between citric acid and sodium bicarbonate?
Okay, I could flip it around and turn it into a question. That's what you're going to be doing with your groups when I tell you to move. Okay? These 4 are a group. You can move right away and write your testable question. You 3 will be a group. Write your testable question. You 4. Let's mix it up and say,
Why can't we be next to
I like Kevin and Leslie. You can switch places with Carlos and Gio. No? How about this? How about this? Go ahead and you guys swap places. And I just want to see how these groups are going to work. So stand up. Swap spots. You guys will be over here. I want you guys together, and then I will take Dio and Lewis. You can join these gentlemen right here. Yes, for your groups. Quickly move. You're writing your testable question right away. Write it down. Mine. Thank you. Okay, and I want you guys to split up. So Carlos, you will join this group up at the front. And then Gio, I would like you to join them up at the front, okay? Yeah, Tony. Okay, you guys are writing a testable question. Write that testable question right away. What did we say it could be? Write it down. Start writing.
We have to put temperature and surface area or just one?
So for you guys, I want you to decide which one would you like to test today? Surface area or temperature? Choose as a group and write it down. Class, for your statement on your testable question, you want to choose as a group which question do you want to test? Surface area or do you want to test temperature? And you're going to write that down with your group. Okay, write your statement. Start by writing it in questions.
Oh my God.
Yeah. And let's think about which variable do your group want to test. Surface area? Okay, so start by writing your question. Yes. So you got it? Nope, we're not at hypothesis. I'm just thinking. And I'll show you when we get to hypothesis, it's right on the back.
Will the surface area affect the experiment?
So that's a question that you could ask. We want to investigate that today. Start by writing it down.
The rate of reaction.
Okay, take about 30 more seconds to finish writing your testable question, and we are going to move on. Take that 30 seconds to write it down. You're going to choose one, so which one do you guys choose?
I don't think it's the other way around, that's why I don't think I understand.
So will temperature affect the rate?
Would an independent variable be the time?
Will temperature affect the rate of our chemical reaction?
The rate of the reaction.
Independent variables is going to change by itself. The dependent variables is going to be
So water.
The temperature. That's in the variable.
Okay, so now that we have begun writing